Hello everyone, welcome to this week's devlog for Clustercraft, Strong Compute's 3D Compute Manager. We have a bit more to show you this week regarding shapes and images, specifically the allowing of you to create clusters based on a default shape and to create roughly your own shape in the browser. So originally we were doing it through secret dev cheats, but now we're able to bring that forward and allow you to do it yourself. So the first thing you might notice is we've updated how nodes look. If I zoom in here, sort of maybe move the camera around, and you can see that each one has now been stamped with the amount of vCPU accelerators on them, and every node has a set amount of vCPU accelerators, as is with real life. We did a lot of research into specifically AWS, which is what Strong Compute supports at the moment, and what information that AWS provides the user, and then how we can then display that in 3D. So we've landed on this, which shows, just the amount of hardware that your vCPUs have. This is common across most of our vCPU supports. We've also allowed for nodes that don't have GPUs attached, so it's only the vCPU cores on those nodes, which allows you to run different sorts of programs on them. We will show you real quick how to create a cluster using a shape. So if we hit the create cluster window, we've completely changed how it looks. So originally it was just changing the GPU type, and that's all you could really do, and then a certain amount of nodes that you wanted to add on, and that's the exact same in game mode still. We've left that as is because we believe that provides a bit better gameplay experience, but for sandbox mode, we've given you a bit more options in exploring and creating stuff however you see fit. So we've got our name still, and if we hit this drop down here, you'll see all of the different cluster shapes that Strong Compute supports. So if I click, let's say this one here, sure, you can see it auto fills in all this information here. So we can see a set amount of vCPUs, a set amount of RAM in gigabytes, and then the GPU type and the GPUs per node. So, sorry, if I update this, I can change this to whatever I want. Let's say I want to go back to, say, B200s. You'll see that it updates the shape because we're not using a default shape anymore. We're using a custom one that we've created. And we can then change this however we want and muck with these. And then we can hit create cluster, and then we can see it then creates that cluster adhering to the information that we asked for. It updates the text on top, it updates all the GPUs we want, updates the cluster text, and ripples all out to the 3D for you. So it's just a way that you as a user can better fine-tune your hardware, especially in sandbox mode, and then allows us to provide better pre-built content for you.
In addition to the vCPU visualization and the improved shape support, we have some improved rendering tools, which for now are going to remain internal, but we wanted to show you anyway because it's really cool. So we've been setting up the CM to act as a tool for rendering really, really large data centers. But as you can tell, if we pull up our debug stats in the corner, it kind of tanks your performance if you're trying to render a lot with like a really large render distance. While it looks really cool, it's not super performant. And obviously we're hitting 21 FPS on average. That's because we have so many post-processing layers. We have bloom, we've got shadows, we have all of the the GPUs sized properly and sort of calculating how hot they're running, and that's taking a big toll on the system. But we do want the videos to look nice and smooth for when we show it off to the world. So what we've done is we've created a way for the browser to render out a video for us, just like you might expect a 3D rendering software like Blender to do it, where it will take its time with each frame and sort of render the entire thing into blobs of images and then stitch the images together as a final video. So here's an example of what you can achieve with this. This is the cluster we just showed here. As you can see, it's running at full 60 FPS, and this one is 1080p, but feasibly could hit any frame rate and any resolution you want, provided that your computer has the memory for it. If you run out of memory, you're not going to be able to show the entire thing. And it includes the outro for us and everything, so now we can model any data center we want in our tool. And even though the real-time rendering isn't super performant, that doesn't matter as much anymore because the final video output is going to look fantastic. Real-time performance is, of course, still really important for game mode, but it is way less of a concern now for any sort of visualization purposes. So yeah, that's what we've been cooking up here. Still a little buggy when it comes to overlays and the usability, the text side of things, but as soon as that's all cleaned up, this is going to be a monster of a rendering system. So yeah, that's what we have to show you this week, and we'll see you next time.
See ya.